Wait, ah. Okay. So you look at page 12 lah. Can take out notes and look at page 12. Okay, can write down the meaning first. The meaning first. Because some of them, right, some of them went to will go to Mandarin class later, ma. Yeah, so uh I don't know if English class, I think I got people, but not so much lah. Maybe they just okay. So you can write down the meaning first. The proton number is the number of protons. Then the meaning for neutron number is the total number of proton and neutrons. Uh, this one this meaning you have to know lah, because they will ask one normally. Very common question lah. And right first. Can I finish one? Okay. So state a number of electrons in atom T. Okay. So atom T, number of electrons. Okay, so atom means okay. Atom means, remember the word atom means the number of proton equals to electrons. So remember on top, right? The number what it represents on top. Nucleon. Okay, nucleon. Then on bottom, proton. Okay, bottom one, the smaller number is proton. So if you look at this, okay, so for atom T, the electron is 19, because as I told you that proton equals to electron, but it is atom. Okay, number of neutron. Remember neutron, okay, so the formula is proton plus neutron equals to nucleon number. So if you want to find neutron, means you use nucleon minus proton. So you will get 20 lah, because 39 minus 19. This one can. Okay. Define a isotope. Okay. Also, one of the meaning they commonly ask in exam in chapter 2. I start with chapter 2 first. Then later on you focus more on chapter 3 lah. Okay. So I stop meaning the keyword here, 3 word. So atoms of the same element means if carbon 12, carbon 13, carbon 14, all are the same lah. Same element, same carbon, same chemical. Okay. So they also have the same proton number. Same proton number means like carbonate. Let's say carbon 12, carbon 13, carbon 14. So you got 6, all have 6 electrons. Okay. But the problem is number of neutron different. Or you can say nucleon number different. Okay, like got 12, 13, got 14. I'm sure this one you learn it. Chapter 2. Okay. You still wake up. I mean like you just wake up or not only. So you still in the activation lah. I mean like activating yourself lah. Okay. Marvel state lah. Aiyo. Why? Wait and drink ah. Okay. So which pair of atoms isotope? Yes, they ask which one isotope RSTU? Who and who? Who and who isotope? Who and who means who and who have the same proton number but different neutron number, different nuclear number. S and U, right? So you can say that. You can explain why? Because you explain that it's around the same meaning as your definition. Okay. So you can say atom S and U have the same proton number, different nuclear number. Chapter 2 is quite a bit easier. So I think I will not focus on too much and do a lot. I focus on chapter 3. Yeah. I think writing down can can also for me lah, sometimes writing things like is one of the way to keep myself awake lah. Okay. Not sure for you. Some people not lah. Some people they like they more you get sleepy lah. This me no like I think. But unfortunately for science subject like have to write a lot lah. Okay. I think more on MS lah, but for maths lah, but for chemistry, certain part lah. Yeah. Okay. So state two different physical properties when between two isotopes. Physical properties you can talk about. Normally you see the word physical properties that talk about the melting point, boiling point lah. Or talk about its density, talk about the atomic mass, all this. Wait, I think there's people joining. And I ask. Will the two isotopes react the same way when heated with oxygen? Yes, explain. Now, this is just now third one talking about physical properties, ma. Physical properties. Okay. So physical properties means what they have their own. But they say heated with oxygen gas. Now, this one not talking about physical properties, talking about chemical properties. Okay, chemical properties. So now isotope, right, they have the same physical properties, but they have different chemical properties. So they say lah, you should say, I mean, so sorry. They have different physical properties. I also haven't awake. Okay. So so physical properties, they have different. Let's say carbon 12 like is heavier, is lighter than carbon 14. So but in this case, for chemical properties means they will get the same. Okay, same. So doesn't matter with carbon 12, 13, or 14. They will react with oxygen in the same way. So isotope have the same number of valence electrons. Okay. So that's why they have the same chemical properties. Because actually like this carbon all have the electron enrichment of 2.4. So they have four, all of them have 4 valence electron. So that's why they react in the same way. Some people also blur one. They are in the waiting room. Just like you just now. Okay. Okay. Okay, done. Okay, then they also might ask isotope for which example and what are the uses. So if they ask what are the uses, right? So you can say medical wise, you got the cobalt 60, most common one, which is to treat cancer. Then the agriculture talk about the phosphorus 32. That one used to use as a fertilizer to for the absorption for plants one. Okay. Then archaeological is carbon 14. Okay. So carbon 14 used for your carbon dating lah. To estimate. Remember, the one this one is to estimate the age of fossils. Not only age fossil, like the age of bone. How long has the bone exist like this? Okay. Industrial sodium 24 lah. This one is to remember when you have underground pipe leaking, then you can check lah which exact location lah. Okay. Sure, this guy one too. Okay. Okay. Then suggest the physical states of substance PQR. Okay. Uh, at room temperature. So in this case, okay. So in this case, this one, when they give you like, okay. So when they give you melting point and boiling point, this table, right? So what you should do, very simple one. Now, melting point means what? Melt, melt means from solid state to liquid state, right? So solid melt to liquid, you can write like this on top. Okay. Then, boiling means liquid boil to gas. Liquid boil to gas. So room temperature means 25 degrees Celsius. Sometimes they might say they might ask in 100 degrees Celsius. Sometimes they might ask 25. Okay, so if 25, so you just look at it. You just arrange it based on the ascending order like this. So like not here. So for P is the 25 is greater than negative 89. Okay. So qualify as gas. Then if it is Q, right? The Q, the number 25 is between 15 and 70. So that's why that the physical state is liquid. Then R is smaller than 900, so it's solid. Okay. They might also ask to the F question, they ask to find the relative atomic mass for the whole element. Means they might ask to find average lah. That's why they give you two lah. Boron 10, boron 11. So they might ask, they want to find the average. Okay. I will not discuss the notes part, okay, because the one you can go back and look yourself. Okay, but the exercise we will do together. Okay, so what happens is now, very simple one. You just use 19.9% times 10. Then you plus 80.1% times 11. That's all. Yeah. So the answer is 10.8. Okay. So sulfur has two main isotopes. Yeah. Sulfur 32 and 34. This one is a bit tricky lah. Now, for F, right, the straight away can find it. You can straight away can find ma. So, but for this, they give you sulfur 32 and 34. They didn't give you how many percent lah. They give you like, oh, they give you this, like sulfur. They give you 32.1. So they ask you how many percent. How many percent contain for sulfur 32 and sulfur 34. So what you should do? Now, if you only got two isotopes, right? Very simple one. If you only got two isotopes, means total is 100%. So let's say you assume sulfur 32 is Y%. For S34 should be total is 100. So you just use 100 minus Y%. If they come out this tricky question. Okay. So it's the same method. But this time you use what? You use 32. Okay, 32 times Y plus 34 times 100 minus Y. Like this, then over total 100, same thing, 100%. So the total is, now the total is how much? The total is 32.1. Okay, so that's why you open up bracket, you will get like 32.1. Okay, open bracket 32.1, then 34 open bracket 3,400. Then you got 34Y. So you minus 34. Then the 100, you move to the other side like mass. Then it become times 100. Then you get 3210. Then others it just mass. Why? How much do you get? Why? Yeah, do you get I think I already answer. I didn't know. Okay. So the divide the 95. So 95 means sulfur 32 is 95%. Okay. Then because sulfur 34 is 100 minus 5. So that you get 5% for sulfur 34. Okay, done. Okay. So yeah, after that, I think you can look at page. Okay, I think the other question I try to do yourself. Okay, you can try to do yourself. Okay. So let's look at yeah, let's see. Page 16. Yeah, the other type, right, is around the same like the isotope, all this. The one I will not discuss so long. So you can try to do yourself. After for those questions that I didn't discuss. Okay. So page 16. So question 2A, right? Diagram 5 shows the apparatus setup used to investigate the melting point of substance S. Okay. So this one, this experiment, I'm sure you have done in school. Right? So heating the naphthalene. Okay. So why is water bath used in the experiment? Remember this experiment? So you put thermometer to measure the temperature lah. There is a time, remember, where the temperature won't change one. That's called, remember, there's melting point. Right? Okay, when you're heating the solid naphthalene, when it turn to liquid, there's a certain time that the the temperature will stay constant. So remember this one. Okay, this is when the physical state is changing from solid to liquid. Okay, so they might ask, why water bath use? Water bath use there because why? Now, why you don't? You might ask why you don't just directly use the Bunsen burner to heat the why don't I just do this? I just directly heat without any water. Why now I need to use water now? Because you can say make sure the heating of naphthalene is uniform. Yeah, because if you directly heat no lah, my teacher very teruk. Didn't do meh? Heating of naphthalene, form 4 chapter 2. Didn't do most schools do mah? Didn't do so funny one. She don't know can be huh? Oh, interesting. What do you mean that she don't know can be? So she don't know how to teach at all. Before Raya, different teacher, now different. Change teacher. So funny. Okay, so I explain to you a bit. Okay, so because this one when you just directly hit there's one problem so you might only hit the temperature let's say here is maybe 85, but maybe the bottom part and the top part maybe only 70. So that's why the part is not even. They want to make sure the whole part is 85 together. They don't want one side is 80, one side is 90. Don't want. Okay, they want to make sure all are even. Okay, so water can do that. So you heat the water will warm up the naphthalene. That's the way Okay, and also because you cannot hit directly to heat naphthalene because naphthalene is a bit explosive I would say it's a flammable substance, can catch fire if you just straight away hit. Most school do so they do man. They didn't do one. You change teacher. Is it change to new teacher? Then the new teacher don't know how to teach. Like this This is what you say. Real one. Oh. So sad. So sad. Yeah. Oh my shit. Oh no. Okay. So what is the purpose of stirring? Stirring is around the same theory They want to make sure the temperature is uniform. Ayo, like this GG Then when she come back last week only pregnant Oh no. Okay. Last week only pregnant. Then maybe 3 months 3 months for the maternity leave Very long she no come school. Oh, already very long time Now her holiday finished. Only finished So recently she just came back. Haven't come back yet. Haven't come back. Okay. So if Safan has come back already, so the teacher they are talking about now is the one that a pregnant teacher came back I don't know which one is the real teacher or fake teacher. She said we do experiment next week. Next week Yes. Which one? It's still in chapter 2 Okay, so if substance chapter 3, the magnesium oxide one so this one you didn't do skip already sad You ask your teacher what I want to do. Okay, so if substance S is replaced with substance Q, but teacher taught you this chapter, but they didn't do with you the experiment. Okay, so if substance S is replaced with substance Q that has the melting point of 109, is water bath suitable to be used in the experiment? Okay, so in this case Okay. So my what is the boiling point of water? What is the boiling point of water? I think this one you learn in science also, right? 100 degrees Celsius. Okay. So I change now I I I change let's say okay my normally my melting point uh my melting point for eh, wait, okay, for the naphthalene is around 80 degrees Celsius. Okay, 80 degrees Celsius. Okay. So when I want to when I change let's say I change this okay. So because normally this one is melting point so I change to the one that have 109 degrees Celsius. Do you think I'm able to melt the melt the substance S? I mean substance Q. Cannot. So because 109 but my water only maximum my boiling point only can reach 100 So 100 how can I get 109? Okay. So that's why you can say that no, because the boiling point is just for water, it's just 100. Okay. Then the melting point of Q is higher than the boiling point of water. Uh, okay. Okay. So this one try to do yourself. It's the same method as the previous question just now. They give you copper 63, copper 65. Copper 63 has 69.17%. Copper 65 has 30.83%. Okay. So they want to find the average relative atomic mass for copper. So you try B1 and 2 Okay. B2 also B2 the balik question You can refer a bit of the last question also. The previous page. Okay, so they give you thallium 203 and thallium 205. That is 204.4 They say what is the percentage? Try to do and give me an answer for B1 and B2. If you don't know, you can tell me. Can hope your hope hope you're on the condition now have 100%. Yeah. Okay, what's the answer? Huh? 600 36. Ah, wait, oh, is it, we're talking about 63.61, right? 62. Oh, I'm curious why you got 636.101. Typo. O is X. I thought times. Oh, oh. uh, no, times, correct. 60, okay, wait. 63 times 69.17 plus 65 times 30.83 divided by 100. Do you get it? Can I? Then the second one, divide by 100. Also, not 10, sorry, 100. Then the second one, you can assume you can assume Y% of X% also can. Any unknown. How much do you get? I also haven't eaten my breakfast. No. No. Okay, can get, can get. Don't know if you see a bit blur. Okay? 哪个 answer 啊 Max error. Ah. Wow, what do you calculate? Okay. So assume tandem 203, let's say X%. So you only got two isotope, right? So you get 100 minus X, right? So you get something that's correct. 203 multiply X% plus 205 multiply 100 minus X. Okay. So do math. This one is a mathematic lah. Okay, mathematic problem lah. Okay. So you multiply 100 to this, then you will get this amount, 20440. Okay. Then you open bracket lah, 203x. Then 205 you can open bracket. 2 205 times 100 also times negative x. Then you just math lah. The other just math. Okay. Do you get this side? The answer won't be math error lah. Okay. The answer is 30%. So then the thallium 203 is got how many percent? 30%. Then the 205 should be 70%. Okay. Then how many proton and electrons are there in lithium ion? Okay. So lithium, the proton number is 3 ma. Okay. So it means what is the electron attachment for lithium atom? lithium atom is 2.1. Remember this one? The maximum for the first shell is 2 electrons. The second shell and the third shell can fill up 8 electrons. Okay. So if you become lithium ion, like this lithium ion, lithium ion, it means they want to become stable. They will donate because here you got one extra valence electron. So they want to donate out. So donate out means I want to throw it away. So lithium ion, now the electron arrangement become 2. Means electron become 2. Okay. Then electron become 2, but proton is still 3. Okay. When they become ion, then the proton same, but electron will be changed. But atom, atom, if they ask for lithium atom, then 3 proton, 3 electron. Okay. So any question with this? Okay. So if no question, let's look at 2B, page 17. Next one, your exam, I think so. Most of you lah. Okay. So you come out and take chapter 3 lah. Okay. So the melting point, boiling point of methane is -182 degrees Celsius and -162 degrees Celsius. So a student plotted the heating curve of methane as shown below. Label the temperature X and Y. Now we have to identify lah. Okay, identify which one is the melting point and boiling point. Okay. So notice this one, the constant temperature, the temperature that has no changes during the specific time. So this one is now at the beginning should be what? When the heat at the beginning is solid. Solid, P to Q is solid. After that is solid. Now S R to S is liquid So Q and R, Q to R supposedly it means supposedly to be solid plus liquid. Means solid is on the way, remember? On the way changing to liquid. And R, S and T, S and T also same. The liquid on the way change to gas. Then the T to U is gas. Okay. Then what is the physical state? I mean, what is the temperature? Now, Q to R, they say -182 is melting. So melting means solid to liquid. So supposed to be Y. Y is the one that is -182. Then the -162 is boiling point, which is at X. -162, which is boiling means liquid to gas. Okay. Then state the physical state of methane at the region PQR. This one you can write down. Okay. PQ is solid, RX is liquid, ST is you can say if you got mixed, it's a mixture of liquid and gas. Half lah. I say half. Okay, maybe at the beginning it's like more towards liquid. At the back, maybe towards most of them already become gas like this. Oh, damn. Okay. Describe in terms of motion and distance the behavior of methane particles at region TU shown on the graph. So you can say that you can say particle are far apart from each other. TU, they ask for TU. TU means gas. I can say that gas means they move very fast. Their distance also very far from each other. So you can say the particles are far apart from each other, can move freely and randomly. Then you can draw the particle for -182. Now, -812, the particular moment is this one, -182, right? So -182 is solid plus liquid. Okay. So if they ask you to draw it, now you draw like half lah, okay? Half of them are solid. Half of them are solid. Then half of them are liquid. Something like this. A liquid normally you draw 2 by 2 lah. 2 by 2. A bit of gap, but 2 by 2. Okay. For gas, you just draw very far apart. If they ask for gas. But for liquid and solid together, you just draw a bit half. Half solid, half liquid. Okay. Okay. So explain why the temperature of methane remain constant from Q to R. This one, they like to ask you to explain one. Okay. So you can say the keyword here, heat energy absorbed is used to overcome the forces of attraction, so the solid can turn into liquid. Okay. Then diagram. This one you answer it. Okay. No. Okay. Can I now? Normally they ask lah. Okay. From Q to R. When you hit why the temperature won't change? When the temperature remain constant, like the negative 182, right? Why there's a particular time staying constant? So they might ask you. So for heating, right? For heating, this is the answer scheme. You have to write. So heat is absorbed. Okay. Because when you heat, like the particle inside the particle, right? When you heat, inside the particle, water particle, all this we absorb the heat from the flame, whatever lah. Okay, absorb the heat. Then the solid are able to be broken down, become liquid. Able to be broken down to be separated, become liquid lah. Okay. But that time, right, the heat energy that already used to break down the particles. You don't say break down, you don't say break down, you say overcome. Okay. So instead of increasing the temperature. Okay. So diagram beside shows the cooling process. Meaning of freezing point. Can I down? So liquid change to solid. Freeze frozen. Liquid frozen to gas solid. Now this is standard answer. We have to say the specific pressure. Okay, constant temperature, liquid change to solid at specific pressure. They might ask okay, so they might ask other than freezing point, they might ask, sometimes they might ask melting point. You just change the answer, change from the solid to liquid. If they ask boiling point, then you might change to liquid to gas. But the answer scheme is around the same. Okay, you have to write the keyword. Explain why the temperature remain during freezing. Freezing because now you see when you got heating, right, the answer scheme is this. For cooling, right, for freezing, right, there's a bit of a different explanation. Okay, so heat loss to the surrounding is exactly balanced by the heat energy released as particle attract each other to form solid. Okay, tak balik. Okay. So example this is your liquid. Okay, liquid. When you get frozen out, right, so inside the heat, all will come up. Then inside the heat, all will come up. All will come out, right? Then slowly, all these liquid particles trying to attract with each other to form a combined particles, which is solid. Okay. But this is answer scheme, by the way. The heat loss to the surrounding is exactly balanced by heat energy released. So in exam map, if they ask like, if heating, why the temperature don't change? You write this. If cooling, why the temperature don't change, remain constant? You write this answer. Can I? Then the cooling graph, I can try to draw first also. Cooling means going down, temperature going down. But of course, again, there is a specific time where the temperature is constant. Okay, so liquid change to solid. The freezing point equals to melting point. If melting point is 80 for naphthalene, for freezing also 80. If they ask you to draw the heating, the heating is just going upwards. Okay, but normally you draw like this. The graph, you draw something that is don't draw the sharpened one. Okay. Any problem? Okay, so done. Done. Okay, so if you're done, then okay. Oof, I don't know how to do this or what. Okay, so don't worry. Okay, you can look at page 19. Since you late enter a bit, so to this room, I also end a bit later, maybe 15 minutes. Okay, so page 19. Okay, so arrangement of particles. Now, this kind of question is like essay. Okay, a bit of an essay question, 12 marks. Okay, so if they ask you that 12 marks, now, so if they come out this one, very easy one. Okay, I'm sure you also learn a lot in science, right? So in this case, they ask, compare the properties below in terms of the arrangement, movement, attraction force, and kinetic energy. Okay, so for solid, liquid, and gas. So for the solid, what happened? The arrangement, I can say tight and compact, all this, okay, closely packed together, arranged in an orderly manner, they arranged properly. Okay, liquid, a bit further apart. Okay, not so arranged. Okay, arranged but not arranged properly. They still in energy but not properly lah. Okay. Then I guess you can just say very, they are very far apart from each other. I want to eat a bit. Movement. Okay. Movement. So can solid move? Do you have gap? No. So you can say can move but only in a fixed position. Okay, maybe rotate in a fixed position. Can move on. Okay. Liquid. So liquid can move, constantly moving around. Gas, gas not only can move, but they can move very fast. Attraction form is the particle and the particle, right? So now for solid, that is very strong. Okay, very strong. They can attract to each other. because there are a lot of particle ma. Okay, the forces of attraction very strong. Okay, let's say inside or inside this got like 100 people. Let's say this one 50 people, this one 10 people. I'm sure like 100 people together their force is very strong. Okay, but for liquid only got 50 people so a bit weak lah. Okay, so for gas it's very weak. The energy rise also okay, very simple lah. For solid is no energy, very low energy. Okay, for gas very high lah. Okay, done. Okay. Now there's another question. Okay. Figure 4 shows the heating temperature of acetamide over a period of time. Explain the state of particles at stage PQR. So this one also 10 marks. Okay. So they might give you this way, they might give you this way lah. Okay, in terms of graph. So for P, solid, very simple. Okay, solid. So you can say around the same lah. Okay, so you can say particle absorb heat energy. Then you can say kinetic energy increase. At the beginning, solid just stay there, not really have energy one. Okay, just fixed. But you try to heat up, trying to heat, use the fire to heat. I'm sure now when you heat, like let's say I put you under the sun, so I'm sure uh you won't sitting there calmly like maybe now you sitting under the aircon under the fan watching me talking ma. Okay, so if now I put you under the sun, of course you get your energy you can pump out lah. Okay, you start to activate. Okay, so and the particle also you vibrate faster. Okay, then stage Q will absorb heat energy, but the heat energy, notice the temperature is constant constant. So the heat energy will not use to increase the temperature, but will trying to change the physical state of solid turning to liquid. So you can say heat energy used to overcome the attraction force between particles so that it started to move freely. Some of the particles, not all, but slowly okay, some of the particles started to move around. Then it started to get melted to slowly become liquid. Then stage R, particle absorb heat energy, same thing, but this time you vibrate, you move faster. Not only vibrate, but you move faster because it's already liquid. So when you're heating liquid, then the liquid also, the kinetic energy also increase. Now if they give you the body graph, they give you freezing same lah, you just twist a bit only lah. So particle will release heat energy. So when they're going down, when it's freezing so but kinetic energy decrease. So it becomes vibrate slower and slower, something like this. Okay. But maybe it's just that here maybe the sentence change a bit lah. Okay. Just now I told you the heat released to the surrounding is exactly balanced by the heat energy used to heat energy release to form to attract each other to form a solid. Okay, done. Wow, I think you're writing very fast. Okay. So If you then look at page 20. Now, I'm sure in school, like you learn two experiment for Form 4 Chapter 3, ma. Okay. Now I start Form 4 Chapter 3 lah. So the one with MGO and the one with CUO, right? Okay. So the CO lah, I talk about CO first, then I go to MGO lah. The CO, okay, write down the empirical formula first, the meaning. Meaning, can you ask anything lah? Can ask proton number, nuclear number, melting point, isotope, empirical formula, molecular formula. But I normally you say you normally settle the other thing first before you focus on the meaning. Meaning you put last normally. Because this one require a bit of memorization. To show the simplest ratio of atoms. Remember, like you got C2H4, right? This is the molecular formula, the actual number of atoms, the real formula, right? So, but these two elements can divide by 2. So I will get the empirical formula CH2. The ratio is 1 to 2, simplest ratio. Cannot be divided anymore. Can I? Okay. How do you dry the hydrogen gas? Now this one, this experiment, I think I explained in class already, ma. Okay, so I will tell you lah. Okay, so what happens is you are hitting the CO, right? Okay, you are hitting. Wait, I move up. Okay, you are hitting the CO, right? Not Cu, you're hitting the CO with what gas? With hydrogen gas. Remember? So because hydrogen is very reactive, right, compared to Cu. Okay, hydrogen is more reactive compared to copper, remember? So what I do? Hydrogen will run past the O away from the copper. I will try to run past away because hydrogen is stronger, it's more powerful. So Cu is weaker. So Cu cannot protect the O. Then if H take away the O become H2O, right? Then now the Cu becomes single. Correct? Okay, basically this is an experiment, but the setup, right? Now you might ask, then how do I get hydrogen gas? Now this is your CO. Okay, this is your CO. But how do I get H2? Now H2 is not surrounding. Okay, normally the gas that we breathe is oxygen. So we have to do, and you have to make something to produce hydrogen gas. So what I do? Zinc plus, okay, so you put zinc into the hydrochloric acid. So we put this. Then in this case, the hydrogen gas will be produced. It will be produced. Then the balance equation. So you produce hydrogen gas from this reaction. Okay, from this reaction. This reaction will produce hydrogen gas. Then the hydrogen gas will flow and react with CuO. React with CO. Okay. So they ask how to dry hydrogen gas. Now, how to dry? Okay, one more thing. How to dry means you put the calcium, correct? The anhydrous calcium, correct? CaCl2. It's a bit similar to do you all know your moon cake, right? Or some certain other food. Inside got a bit of a plastic one. A bit of a package. The package inside is similar to this function. It's just to make sure inside it's not moisture, it's not wet, it's no water. So to make sure this one also the hydrogen gas can be dry can be dry. So then what is the purpose of using zinc granule and hydrochloric acid? It's just to produce H2. Just want to get the H2 lah. The equation I written just now, Zn, zinc is Zn, hydrochloric acid is HCl, arrow, ZnCl2 plus H2. Then you got 2Cl and 2H, right? So you times 2 for HCl. Okay. What change can be seen after the oxide of copper is heated strongly? Okay. So if it is heated strongly, then at the beginning, CuO is black color. Okay, black color. After that, when you heat like CuO becomes Cu, the Cu, the copper is brown color. Okay. So you can say what can you see? What can you observe? Black solid turns brown. Okay. Then determine the empirical formula. Now this one, very simple one. Also, this one is the first one, first mass. They will measure the mass before you start the experiment. After you put copper oxide, okay, and after you heat the copper oxide, which become copper. Okay. Then, if you want to find the mass of copper, you just minus Yeah, highlight for you. It's the mass of combustion tube. Okay. Okay, together with the asbestos paper. Then this one is the mass of copper. Another one is the oxide. So if you want to find the mass of copper, how? 2 minus 1. Okay, you cut off. Then you get the mass of copper. Okay. Then if you want to find mass of oxygen, 3 minus 2, cut off copper, then you get oxygen. What do you get? I believe this number, right? Then remember this one, if you want to find empirical formula, what you should do? You should do the number of mole. Remember, number of mole can be mass equals to molar mass. Since here they're talking about mass, talking about how many grams. So just use 12.8, okay, divided by the relative atomic mass, 64. The other one is 3.2 divided by 16. Yeah, 0.2. So very simple. If you get 0.2 means for the ratio, you just both divide by 0.2. Now, if you get different number, what you do? If you get different number, you divide the smaller number. Okay. Now, in this case, you just divide the same thing for the ratio, which you get 1. So 1 to 1 means the formula is CuO. 1 Cu and 1 O lah. So can no problem. Okay. Then the equation for copper oxide and hydrogen gas. Oxide of copper is CuO. Hydrogen gas is H2. Okay. Then you get Cu plus H2O. Why does the hydrogen gas need to flow continuously for a while before starting the heating process? Okay. So why hydrogen gas have to flow? Now, this experiment to make sure you always flow the hydrogen gas even before, during, and after experiment. Because they don't want any oxygen to enter, or they want to get rid of the oxygen before the experiment. During the experiment, they want any oxygen to enter so that they don't want to catch any fire. They don't want to kill it explode. Because oxygen and hydrogen react like. So when you let oxygen to enter, especially when you're heating, because when you're heating, the temperature is very high. So you might easily catch fire. You might easily explode. So that's why before starting means you have to remove all the air, all the oxygen from the gas tube. So because this experiment is CuO plus H2, not CuO plus O2. Okay. And the empirical formula of magnesium oxide. Now, magnesium oxide cannot do lah. They must can I do this? Can I do MgO plus H2? So the answer is no lah. Okay. So because in this case, MgO, the Mg is more reactive lah. Okay, MgO, the Mg is more reactive. Okay, compared to H2. So the H2 cannot run past the O away. So it means forever you stay like this, forever no reaction. Yeah, can I? The hydrogen gas is allowed to flow until the product of heating is at room temperature. So even after heating, this one is after heating. After heating, when you're cooling down the when you're cooling down the product, which is the copper, you have to let the hydrogen gas continuously to flow. Because why? Because to prevent air from entering. Okay, to prevent any oxygen to enter. Okay, so that because now if you let the hydrogen gas to enter, do you know what happened? So let's say okay, this one okay, so after experiment, you let the oxygen enter. Even when you close the fire, now because the copper copper the final product you get copper but the copper is still hot right? It's still hot So when it's still hot let's say some of the oxygen enter So that's why the copper easily react with oxygen to form copper 2, go back to copper 2 oxide. Do you think I want that? My experiment is I want to turn from CuO to Cu How can I want my Cu go back to CuO? Okay. So that's why I will prevent any oxygen to enter even after the experiment, even when I cooling down the copper. Okay. So you can say to prevent air from entering, because if you let the air to enter, we react with the hot copper, which will go back to copper oxide, which you probably don't want that to happen. You can write down. We do one question, one or two questions about the MgO also. Okay. Why do the heating, cooling, weighing process need to be repeated? Now, this experiment you have to repeat. Okay. Until why? Now, this doesn't matter with CuO or MgO, right? When you heat that, you have to repeat these processes because like let's say lah, at the beginning, let's say your CuO is 26 gram. Okay. So let's say your final product is which is copper 24 gram. So when during this experiment, if I get the constant mass like this, okay. I mean, if I haven't get a constant mass, so I will want to make sure my 24 gram of Cu cannot go below anymore. It means I already reached the minimum. Okay. So there's no changes anymore. Then only I can stop. Otherwise, let's say the first time I wait I get 25 gram. Means it notice you got changes now. Okay, notice you got changes now. So that's why 26 become 25. So that's why 25 become 24. So that's why you have to repeat 3 times. Because when you wait you cannot only repeat weighing because when you heat when you heat means the solid normally in white film. Okay? Or normally they are in a gaseous state. So that's why to make sure you have to cool down first. Heating, cool down, they only weight the mass. Okay? So to make sure, what I do is you ensure all copper 2 oxide completely become copper. Okay? So if it is like 24 gram, become copper, now you can stop. Because notice if the mass has no changes, it means all the CuO, all the O has already been burned out. Okay? If not at the beginning, like this, if you changes, it means you're not sure is it 50% or is it 70%, the reaction has completed or not. Okay. If it's like this, then you already make sure 100% the reaction complete. Form 4, chapter 3. I have most school haven't done experiment. I think you've done it. Okay, sorry. This one you won't do experiment, by the way. I forgot already. Okay. CuO you won't do experiment in school. Because CuO is dangerous. The hydrogen gas one is dangerous. Normally you do the MgO one. Okay, this one done. So if you done it, page. Okay, page. We do one question about the MgO also. Page 22. Okay. So this one you do in school normally. Just now the CuO, right? Because it's dangerous, it might explode. But this one is not. This one normally you do in school. I think some teacher already done. Some teacher will do next week. Okay. So diagram 1.1 show the setup. Did before already. Okay, very good. Okay. So so you can write out the molecular formula meaning first. Okay. A chemical formula shows that the actual number ratio of atoms. The real formula. We call it the real formula. Okay. They might ask some meaning. Okay. Molecular formula, empirical formula. Okay. Then same thing. You do the table. I mean to calculate the empirical formula. So for Mg, how do you get the mass? Based on this table, you got 3 different values, right? So same thing. Oh, the first one, okay. The first one only empty crucible. Okay. Then the second one is magnesium ribbon. The third one, magnesium oxide. So if I want to get the mass for magnesium, then it's 2 minus 1. 2 minus 1. So isn't it you get 39.7 minus 38.5? Because I cut off that. I cut off the mass of crucible, then I will get magnesium. Same thing lah. For O is I cut off the mass of crucible, the mass of crucible, cut off the mass of magnesium, then you get oxide, which is 3 minus 2 lah. 3 minus 2. Then after you get the mass up, what you do? You find number of mole, right? Remember, number of mole equals to mass over molar mass. So molar mass normally you get from the relative atomic mass. Which is for O is 16, Mg 24. Normally lah, for MgO you get 1 to 1. Doesn't matter with CO or MgO, you get 1 to 1. Because number of mole, you get the same. Okay. Then you just divide with the same number. Divide with the same number. Then the formula is MgO. Then the equation, how? Okay, equation, what do you burn? Now here, remember the experiment? I'm sure most of you already done. So in this case, you're burning the Mg magnesium. Okay, and you allow the oxygen gas to enter to react with the inside magnesium. Then the magnesium react with oxygen to form magnesium oxide. Okay, remember this one? Okay, and remember some of the precaution where you have to lift up the lid for certain time, from time to time. Okay, just to allow the oxygen gas to enter to react with magnesium. You have to close it back as well because you don't want the white film inside, the white film of magnesium oxide to come out. Okay, so equation is okay for you. Mg plus O2 become MgO. Then the equation is balanced equation. I'm sure you have done. So times 2 for MgO, because left side you got 2 oxygen. Then now you got 2 magnesium at the right. So times 2 for Mg. Then why was the crucible covered with the lid as soon as the magnesium started burning? Okay, very good. Very good, Xingyu. Okay. So they say why you have to cover when it start burning? Cover because you don't want the white film inside coming out. Because when you heat that, a lot of white film. Because the white film of which is also the magnesium oxide, so slowly reproduced. So you don't want the MgO to just come out easily, because later on you affect your mass. You want to prevent it from escaping to the air. Any question? No. Okay. Then why is this method not suitable to determine the empirical formula of copper oxide? Okay. So why I cannot do this? Okay, no, just now, right? I did burn oxygen with magnesium. Now they say why this copper is not so suitable to react with oxygen? Because the reaction is too slow. Okay, because copper is not so reactive. Okay, they shouldn't use this method. Okay, copper is less reactive towards oxygen. That's why the reaction is very slow. Copper, silver, all this lead not suitable to do this way. They do the experiment just taught, which is the glass tube one. Can I? Chapter 2 is easy lah. Okay, chapter 3 is the one that is difficult. Difficult where? Difficult at equation. I mean, not the formula. Today, of course, I will teach chemical formula one by one. Okay. So the one that I suggest lah. Okay. If you got time, like, memorize lah. Okay. And the formula, the chemical formula, the ions. Like magnesium is Mg2 plus. All these have to memorize in order to, for you to write down the formula. But today I won't teach lah. Okay. I'll teach other things. Okay. So I explain on how to ensure the reaction has completed. Okay. So, completed means how do we know, how do we make sure 100% of Mg has become MgO? How? Okay. So you have to do what? You have to repeat heating, cooling, weighing process. Okay, until you get a constant mass. Same thing, same with the CO I talked about just now. Okay. So the heating, cooling, weighing, you have to keep repeat that. Let's say this 24 gram of Mg. If you want to become 26, you have to go through a process. Okay. I mean, go through this process until you get the constant mass. So if you want to repeat 2 to 3 times until you get the same mass, then you can stop. This is the meaning. These two precautions, okay, so especially during the heating process. So during heating, there's two important processes I talked about just now. Cover the lid, I mean cover the crucible with the lid, and also we want to lift up for a certain period. Okay, lift up a little bit lah. Okay, so you can say the lid must be opened at intervals. Okay, for certain time. They want O2 to enter. Otherwise, the O2, right, if you just cover for the whole experiment, the O2 cannot enter. Okay, so that the O2 can enter, so that you can react with magnesium, it become MgO. Then the crucible also quickly cover again, so that at the same time, there's one problem also where you don't want the white film escape. You don't want the MgO escape. Otherwise, you affect your mass later on. Okay lah. Yeah. Done? Okay, done. I thought you're not alive. Okay. So I thought you already fell asleep. Okay. Still alive, of course. Okay, I like your spirit. Okay. So in this case, okay. Okay, move on to 6A. Okay, 6A. Sorry, sir, I have to leave early due to my family. Okay, no, no. Okay, no problem, no problem. Okay. Okay. Bye bye. Okay. Okay, okay. Okay, so in this case, diagram 7.1 and 7.2, okay, shows two methods to use to determine the empirical formula for metal oxide X and metal oxide Y. Okay, so what is mean by empirical formula? Try to write your own. Empirical formula meaning. The chemical formula show what? Shows the simplest. Simplest what? Okay, I'll show you lah. So shows the simplest ratio number of atoms. or if you want to add lah, the simplest whole number ratio of atoms. Okay, so suggest method X and Y. Explain why the metal was chosen. Now, very simple lah. Okay, method X. Now this one, okay, the crucible one. So I write for you the reactivity of metal. So remember you got this. I think you learned in science also, right? My memorization is kalau kalau nak kawin mesti ada zinc flexible supaya perempuan hasil cukup anak. Okay, so I tell you why I use this. Okay, so for the experiment of this, so you can not only put magnesium, you can apply to aluminum and also zinc. Okay, apply to aluminum, also zinc. Okay, so it means zinc also can react with oxygen, aluminum also can react with oxygen to form oxide. Okay, so this one is for X. You can suggest for X. Then for Y, this one, the copper one, right? Not only copper, okay, it can be Fe, it can be tin, okay, it can be Sn, tin, it can be lead, it can be iron, or it can be silver. Okay, if in exam they ask you lah, but normally lah, okay, if they suggest one, you just put the standard one lah, magnesium, okay, or copper. Okay, magnesium is more reactive than oxygen gas, towards oxygen gas. So you put magnesium. Then the other side is copper, because you can say copper is less reactive than hydrogen gas. This here I say lah, because Mg is more reactive towards oxygen, so you react with oxygen to form magnesium oxide. So times 2 times 2. The one is you don't start from Cu, they start from CuO. That's H2, where the H2 is more reactive, that's more reactive than copper. So you run past the oxide away from the copper to form copper and H2O. Okay. Diagram below shows the apparatus set up to determine the empirical formula of two types of metal oxides. Okay. So in this case, they want to compare the method used in experiment set 1 and set 2. So compare. Now, compare can talk about similarities and differences. Similarity means what is the same thing, what is the common thing between them. So for both sets, it involves heating. Both use fire to heat it. Use fire to heat. Then the reaction is between a gas and a solid. Okay, same thing. Okay, it means this one magnesium solid. I react with oxygen in gas, right? Solid, and the reaction is between solid and gas. Same thing for the right side. Copper 2 oxide, a solid. Hydrogen gas, a gas. Hydrogen, a gas. So it's why easily both the reaction is between solid and gas. This same thing between them. And also both involve heating. Okay. Then the difference. Okay, the difference. Okay, so for set 1, what do you form? Set 1, you form MgO, right? Metal. Okay, magnesium is a metal. can be magnesium, can be zinc. So metal oxide is formed, like MgO. This one won't form oxide, this one form metal only. This one form metal only. The metal is formed. Copper metal. This one is uh magnesium oxide. Different. Okay. Then you can say that very obvious one. One reactor with oxygen gas, one reactor with hydrogen gas. One more, you can say the mass. Now, for the magnesium experiment, the mass you get heavy. Let's say 24 gram, become 26 gram. Now, why? Because you added one oxygen. Then the mass will be slightly heavier. Okay? But for CO, the minus of the O, they take out the O. So the mass will be decreased, supposedly. So you can say the mass of solid decrease. Can answer? Okay, done. Okay, very good. Okay. Okay, so page 25. Okay. Diagram 11 shows the set work of apparatus in two set experiment to determine the empirical formula of oxide of metal P and metal oxide Q. So the first one is the Mg, right? Plus oxygen one. The second one is CO plus H2 one. So suggest one metal. Okay. So for metal P can be magnesium, aluminum, or zinc. In essence, just write one. The reason I tell you this, we got three, because sometimes they might ask in objective question. Sometimes they very tricky one. They give you this diagram, they don't give you Mg. The option, they give you zinc, they give you silver, they give you the different normally don't see one. Because in your head normally is magnesium and copper, but it can be other elements also. Okay, you have other alternative. Okay, then metal P is then they say why is it set one is suitable for metal P? Because you can say metal P is a reactive metal. Okay, so for metal Q, you can suggest any of this. Normally, of course, I recommend the standard answer. So, but in answer scheme, any of this accepted. Okay, then you can say why. Metal P, same thing lah. Metal P is, metal P blood. Metal Q is less reactive. Less reactive than hydrogen. Okay, done. Okay, very good. Okay. Yeah. So okay, so look at page 27. We do a bit of a different kind of question. Okay. So vitamin A, retinol is made of carbon, hydrogen, and oxygen atom. Okay. So they ask to determine the mass of 1 mole of vitamin A. So if they 1 mole, right? 1 mole means they ask the molar mass how much. They want to calculate the molar mass. Okay. So first of all, you have to know the formula. So based on this diagram, help me to calculate how many carbon. What's the formula? Okay, carbon, how many hydrogen, how many oxygen. Okay. How many calculate? Okay. So one by one. Okay, carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, 12, 13, 14, 15, 16, 17, 18. Am I right? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, 19. Am I missing something? 20. Okay. So is it 20? Right? How many calculate one bar? And give me an answer. Hydrogen is 6. So many, so big number. 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 20, 21, 22, 23, 26, 27, 28, 29, 30. Oh, so 30 lah. Now, answer they ask something like this for some certain question. Okay. Then how many O? O is 1. Only got 1. Yeah, only got 1. Okay. So, so the molecular formula is C20H30O lah. Okay. Then how to calculate molar mass? Very simple. How do we calculate? Normally they give okay, H equals to 1, C equals to 12, O equals to 16. So you got 20 O means 20 times 12. C is 12, right? Okay. Then how many H? 30 lah. So 30 times 1. H is 1. Okay. Just one O is 16. How much? 286. Okay, very good. Okay, 286. The molar mass, you give 286. Molar mass have to put gram per mole. Gram mole -1. If they ask you to put, if they put a relative atomic mass, then you no need to put unit. But if they ask for molar mass, then you put unit. Then mass of 1 mole is 286 gram. Do you know what molar mass? Molar mass means in 1 mole, how many gram? So this one exactly I said mass of 1 mole. But for molar mass means in 1 mole, how many gram? In every mole, in every 1 mole. Okay. So determine the mass of 0.025 mole of vitamin A. So this one is simple. So what I do? What is the formula? Number of mole equals to mass over molar mass. So I just put okay, number of mole equals how much? Now equals to be 0.025. Okay. Then the mass is, you have to find it. Molar mass just now how many? Molar mass 286. Is it? Okay, how much? Okay, 7.15 gram. Unit gram, mass. Okay. Determine the number of molecules present in 20.02 gram of vitamin A. That's how to do. Number of molecules. Okay, I write for you the formula. Okay, one more time, just in case you forgot already. Okay, so I still repeat one time. Okay. Number of mole equals to mass over molar mass. Got 3, have to remember. Okay, in exam they won't give one formula. Or volume, sometimes volume equals to molar volume. Okay. Or the number of particles. Over Avogadro constant. Okay. Then the number of mole, the unit is mole. The mass is unit is gram. Volume unit is dm cube. Okay. Or sometimes can be changed to cm cube. Because 1 dm cube equals to 1000 cm cube, right? Okay. Then number of particles. Number of particles can be can be split into atoms, molecules, or ions. Okay, or ion. Then the Avogadro constant is the fixed number 6.02 times 10 to the power of 23. So they ask what? They ask for number of molecules. So we have to use this formula, right? Correct. Okay. And they give you mass. So if they give you mass, you have to start with this first. So you have to start with mass over molar mass first. Okay. So number of mole equals to mass over molar mass. So they give you mass is 220.02 over the molar mass just now is 386 at 286. You calculated. How much? I think you get 0.07 more. Then you use this 0.07 more to find number of molecule. So number of particles over Avogadro constant. Then number of moles 0.07. The fixed number is 6.02 times 10 to the power of 23. Yes. Answer. Okay, very good. Power 20, 23, 22, 22, right? Not 23, I'm sure. Okay. Typo, okay. Okay, so no problem. Okay, so determine the mass of now they give you how many molecules. So okay, now you start with the number of particles first. Alright. Let's start with number of particles first. Okay. You give an answer. They want to find mass. Okay, but they give you number of particles first. Okay. How to give the answer? Okay, 0.125 more than the mass. 35.75 gram. Okay, very good. Okay, I'm sure you know how to do now for this type of question. Okay, so page 28. Okay, banana is rich in vitamin B6. The figure below shows the molecular structure of vitamin B6. Name the elements that is made up a vitamin B6 molecule. So what's the element inside? What is C? C is carbonate. What is H? Hydrogen. What is O? Oxygen. What is N? nitrogen. So you can all name up. Okay, name the element. Okay, so you can name the element. Okay. So write the molecular formula for vitamin B6. So how? Okay, so calculate again what about how many C, how many H, how many O, how many N. So calculate. Okay, so C, 1, 2, 3, 4, 5, 6, 7, 8. So the formula is in 8 carbon. How many hydrogen? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11. Okay, 11. How many oxygen? 1, 2, 3. Okay, 3 oxygen. How many N? Okay, only got one N. Okay, so just leave the N. Okay. Molar mass. So how? You calculate lah. Okay, so I give you like the RM. Normally they give one normally. So for H is 1, C is 12, N is 14, O is 16. Calculate for me. Molar mass. So uh what do you get? Okay, 249. 249. Wait. Am I right or wrong? Wait a minute. 249. 96. Wait, where's my screen? Cannot see my screen now. C is 12. Oh, wait. 1, 2, 3, 4, 5, 6, 7, 8. 22, no 22 12. Okay, carbon is 12. Cannot see my screen. Wait, so funny. Okay, so I can see now, Yeah. Okay, so calculate number of molecules. Okay, so okay, I think this one I skip. This one I skip. Okay, so you can try to do a stuff. Then do the F. Okay, so write the empirical formula for aspartame. So this now is C8H11O3N ma. Okay, so very simple lah. So can you divide anymore? Can you simplify anymore? 8 and 11? No, right? So that's why if the molecular formula is this, the empirical formula is the same. Sorry, it's NO3. It's NO3. Have you terbalik bila? NO3. Okay, yeah. The alphabet is, they follow the alphabetical order. MNO. Okay, so you write N first and O. Okay, sorry. CMNOP. I have to go back to primary school. Okay. So any question this? Okay. Uh yeah, you look at page 29. Okay. So quinine is a drug used to treat malaria. Okay, so they give you all this inside this they contain of all the carbon, hydrogen, nitrogen, and the rest is oxygen. Okay, so they want to find the first column is element. Now this table normally they don't give me an exam, so that's why you have to memorize what you have to write here when you ask you to find the empirical formula. Okay, so you have to remember this part because this table won't give normally. You have to draw up yourself in exam. Okay, so mass. Okay, so remember this one assume lah. Okay, assume 100% equals to 100 gram. So if you got 74.1%, it means you get 74.1 gram. Same thing. Just put inside. Okay. Then the oxygen, the rest is oxygen. So oxygen just minus. Okay. Total percentage is 100. So you just use 100 minus this three number. You get 9.86 gram. 9.86. Okay. Yeah. Then you calculate number more. I think in order to save time, I give you answer. Okay. So now when you get number of equals to mass over molar mass, then what you do is you have to divide. Divide what? Divide the smallest number. Which one is the smallest number? 0.616, right? So that's why all have to divide by 0.616 in order to get answer. Okay. Now sometimes in exam you get 0.5, so something like after you divide it, then you have to, if you get 0.5, normally you times 2 lah. Okay, times 2 to get the whole number. There's no decimal place one. Okay, if 0.5, you have to times 2 lah. If times 2 here, then the whole thing have to times 2. Like this. Now, if here, if sometimes you get 0.33, you have to times 3 lah. Okay, to get whole number. Okay, but here already whole number for everything. So you just put down, okay, 10, 12, 1, 1. Already whole number, no need to multiply anything. Then the formula is C 10 H 12 N O N. N O O N. Actually can also lah. Okay. Or M N O or N O. Okay, N O. Okay. Then the molecular formula. Where's my screen? Why suddenly gone again? So funny one. Wait. No. I keep my screen keep popping out. Okay, then empirical formula. Now, this is your empirical formula. If they ask you to find molecular formula, they give the total mass is 324. Then because you don't know how many times, so you put n times. Remember, you put n times. Okay, n times the amount of empirical formula equals to 324. 324. Okay, then inside you just put the 10 times 12, all this stuff. Okay, 10 times 12 plus 12 times 1 plus 14 plus 16, like this. Then the whole thing bracket n equals to 324. This is how you find the molecular formula. Empirical formula you draw a table. Then after, only if you got empirical formula, then you can find the molecular formula. So I believe you get n equals 2, right? Then C, it means the whole thing, the whole empirical formula, you just multiply 2 lah. Okay, so you get this amount C20H24 N2O2. Okay, so I think I do one more question on wait, let me find a question. Page 32. Okay, do one more question on page 32, then we stop. Okay, is it page 32, page 32 and page 34? Okay, so page 32 now they ask this one a bit of tricky question okay, very tricky question. So in this case okay, what you do is okay, so you got 14.50 gram of fuel X okay, fuel X, okay, then you got 44 gram of carbon dioxide gas, which is CO2, okay, CO2 then you got 22.5 gram of water, H2O. Then they say fuel X contain of carbon and hydrogen elements. Okay, it means this fuel X contain of carbon and hydrogen elements. Okay, so what they ask is they ask for the empirical formula for fuel X. Now, how do we find a bit confusing is they give you 14.5 gram, but you don't know. Okay, C and H, what is the real formula? Okay, so but they give you all kind of mass okay, so 44 gram is carbon dioxide, CO2. 22.5 is H2O. So you have to find the mass of CO2 and H2O first. Then you can do the empirical formula. Okay, now because you don't have the element, you don't have the mass of carbon itself and H itself. You have the combination, I don't know, combination of C and O, combination of H and O mass. So what I do is now, if you face this type of question, now the CO2 is 22.5 gram. So you can use this information. What you can do is now you can find the molar mass. Now you want to find carbon. I do this. So I find carbon. You want to find a thing you put on top. Then you don't want to find it. Okay. The total you put on bottom. Then you times the 22.5 gram. This one, this part, the part you put molar mass. Okay, I'll show you. So one carbon is 12, right? The relative atomic mass. Then bottom is you put total 12 plus 2 times 16. Okay, 12 plus 2 times 16. The total mass is 22.5. Okay. Then instead I will get how many? Not okay. 44. Why you get the 44? Oh, 44. Sorry. Not 22.5. Yeah, so 44. Sorry, 44. I see wrongly. 44 is for CO2. So we have to read carefully in exam. 22.5 is for H2O. So I'm talking about CO2 now. So the total is 44. You multiply 44, then you get like how many? 12 gram. 12 gram. Okay. So mass for carbon is 12. Then for H2O, same method. Okay, H2O. Okay, one. Okay, you got 2H left. So 2 times 1 at the top. Okay. Then you got H2O, so 2 times 1 plus 16. Then for H2O is 22.5, so you put 22.5. Equals to 2.5 gram. 2.5 gram. Okay, then more mole. 12 over 12. Mass over molar mass. Then this one is 2.5 divided by 1. So you get 1 and 2.5. So you just use 2.5 divided by 1. I mean 1 divided by 1 for the first one, you get 1. Uh, this one is correct. 1 over 1 divided by 1. Ui, my so strange one. It's same thing. Okay, so 2.5 divided by 1, 2.5. So one is a smaller number, right? Okay. So 2.5 how? 2.5 how to become whole number? Multiply 2. So you get 5. If the right side multiply, left side also multiply 2. So the formula is C2H5. Right? Then the molecular formula how? So total is 58 ma. Okay, 58. So again, maybe you don't know how many times, right? N times don't know how many ma. 2 times, 3 times, 4 times to know. So you just put N times, total 58. So N equals to 2. N equals to 2 means you just times 2 for the empirical formula. So you get C4H10. C4H10. So if they come out a tricky question, so it's not so easy. They want sometimes a bit like sometimes I don't know, some school what okay, they come up hard question. It's our question. Okay, so not so direct. Okay. No, no, no. Okay, so okay, done. Okay, we do one more, I think. One or two more. Okay, so we do this one. Okay, page 34. Okay. So this one we just done, I think we just done recently. So last week and this week. So how do we calculate the number of mole? But you got equation. Okay, we follow I don't know if a school until here or not. Okay, I send. Okay, so I do here. 9.2 gram of ethanol. Ethanol is C2H5OH. So they give you 9.2 gram. Okay. So they want to find volume. Volume. So volume of what? Volume of carbon dioxide. So carbon dioxide is CO2. So to find volume of this, you write below the element. Below the compound, sorry. Okay. Then you just start with 9.2 lah. So 9.2 gram mass over molar mass. Okay. Then the mass is 9.2. The molar mass, you got 2 carbon. 2 times 12. You got 5 hydrogen. 5 times 1. 1 oxygen and 1 H. Okay. And easily you get 0.2 more. Then you do ratio lah. Okay, the ratio C2H5OH to CO2. Okay. Then the ratio is 1 to 2. No number means 1. Then this one is 2. So 1 to 2. 0.2 means you get 0.4. Okay. So you get 0.4. The molar volume here they given 22.4. So you get 8.96 dmq, right? Okay. dmq unit. Okay, so the volume of oxygen gas needed, okay, for the reaction at STP. So equation, okay, do ratio lah, same thing. Okay. So now they ask for oxygen gas. Oxygen gas O2. Okay, they ask for O2 now. volume, how much? So this one is 1 to 3, right? So 1 to 3, okay. So C2H5OH to O2, 1 to 3. So if you get 0.2, the O2 gets 0.6 mole. After that, you just multiply 0.6, which will get 30.44 dm cube. Then the 8.0 gram of magnesium oxide powder, magnesium oxide is MgO plus nitric acid is HNO3. Now this sort of equation, if you don't know the formula, then it's very hard to write. So that's why I recommend, okay, go back and look at the formula. Okay, I think this is one of the important thing. They have to do a yourself. So produce magnesium nitrate. Magnesium nitrate is magnesium is you have to know the ion is Mg 2 plus. You have to look at the ion back. Okay. Then the nitrate is NO3 1 minus. That's why, and we produce water. So that's why magnesium oxide, because you get magnesium 2 plus, O is 2 minus. Okay, so you can get MgO because you simplify the 2 and 2. Then 2 plus 1 minus 1. So that's why the formula is Mg bracket NO3 bracket 2. Okay, then you plus water, H2O. Okay, then you balance the equation because you got 2H, you got 1H, balance times 2 for HNO3. The rest of the question, do yourself. This one again, all the data question that I didn't do yourself. Okay, then if you don't understand, if you face any difficulty, then you can ask me. You do when you're free, okay, before exam also can. Okay, so then look at last part, okay, page 36. Last one is I want to write the qualitative and quantitative information because they might also ask this one. Okay, so remember how to write. So qualitative means you have to write what are the reactants and products. Remember, okay, and also include the physical state like the liquid, solid, gas. Okay, so you can say lah. Okay, so reactant are the front one lah. Okay, reactant. This one reactant. Okay, liquid propanol and oxygen gas. C3H8O is propanol, oxygen gas. The product is CO2 gas and H2O liquid. This is the product. After arrow is a product. Before arrow is the reactants. This one you write qualitatively. Okay, qualitative information. Then quantitative, just write down how many mole. How many mole? So you got 2 mole of propanol react with 9 mole. You write the quantity lah. Like how many mole? Okay, 9 mole of oxygen gas. Produce 6 mole of CO2 and 8 mole of H2O. Just talking about the numbers. Okay. Okay. Okay, so then thank you for watching. Okay, so I stop here today. The next question you can do yourself. Okay, so I see you again. Okay, bye bye.